Good morning. Again, hope that you're having a good day. Um, I know you guys are probably really starting to miss me at this point. Probably just hate these videos. Again, preferably I would have been here. This is kind of the end of the road as far as you having to hear a video from me. Following today, you'll have the quiz tomorrow. Again, like I said, I know I haven't been here except for the very first lesson on theoretical probability, and that was last week before we got out for a couple days. Um, so I just want you to do your best on that quiz, okay? That's what I want you to do. Just do your best. I expect you to do your own work, and I want you guys to give it your best effort. Again, since I wasn't here, and just you had to learn this conditional probability watching a video. I'm going to go through the homework last night too, just to make sure if you have any questions, they'll be answered. And then also we'll go through the review. So at this point, the review probably should be heading your way. Anyways, I'm going to kind of go through this. I'll try to go pretty fast to make sure I have plenty of time to do all this. All right, so we're trying to find the probability of at least 20 given that it's a prime number. Okay, so again, the given that's got to be our focus, and we're looking at numbers between 1 and 50. Okay, that's what that tells me. So between 1 and 50, here are my prime numbers. We've already kind of talked about this a couple days ago. So we got 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47. I don't think I missed one of those. If I did, I'm sorry, but that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 that are prime numbers. So that's my bottom number, okay, the prime number. Now, out of those prime number, we want the ones that are at least 20. Remember what at least means. At least 20 means 20 is the smallest amount. So we're only talking about the ones that are above 20. So the ones in this group only that are above 20 is 23, 29, 31, 37, 41, 43, and 47. So that's 1, 2, 3, 4, 5, 6, 7 out of the 15 that fit our given that category, given that they are prime numbers. So 7 out of 15. That will not reduce, so that's my answer. Number 4. Blake randomly chose a letter from the alphabet. And y'all know how many are in the alphabet, right? It says, what's the probability that this letter has at least one line of symmetry, given that it is a consonant? So if you think about consonants, any letter that is not a vowel, okay? So I'm going to write them all down, and this will take a minute, but let's leave out A, E, I, O, and U, okay? So y'all know that there's 26. You take out the 5 vowels. My bottom number, my given that's 21 consonants, okay? So here's what we got. We got B, C, D, skip E, F, G, H, skip I, J, K, L, M, N, skip O, P, Q, R, S, T, skip U, V, W, X, Y, and Z. So those are my letters that are what we call consonants. There's 21 of them. You can count them up if you'd like. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So it's 21 consonants, and that's my bottom number. That's my given that. Now, at least one line of symmetry. Remember what a line of symmetry is? A line of symmetry means that you can cut it somewhere, and in that spot, it folds directly over itself. So if we drew these letters appropriately, here are the ones that would have at least one line of symmetry. B does, right there, it folds. C does, it folds. D does, it folds right over itself. F doesn't, G doesn't. H actually has 2 lines of symmetry. J does not, K has one line of symmetry this way. L does not, M does right here. N doesn't, P doesn't, Q doesn't, R doesn't, S doesn't, T does, V, W, X has two lines, Y actually does if we wrote it correctly. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 that actually have at least one line of symmetry. So 11 out of 21 will not reduce, and therefore that is my answer, 11 out of 21. All right, moving on, number 6. A month of the year is randomly chosen. Find the probability that it has no more than 30 days, given that it starts with the letter A. Okay, so given that, remember that's where we start with. How many months start with the letter A? Well, we know it's just August and April, right? So there's only two. There's only two, August and April. So we're trying to figure out of those two, I don't know why I say August first, April comes first in the year. We're trying to figure out which ones have no more than 30 days. Okay, so if it has more than 30 days, it doesn't count. Now, I still have that diagram drawn up on the board. So if you look at it right now, you can see that April is down low. It has 30 days. But August is up high. It has 31 days. So 1 has no more than 30 out of those two. So 1 out of 2. Okay? All right. From this wheel, we're going to answer the last ones, or the next ones. I don't know why I said last. Number 7. We're trying to find the probability that it's black, given that it's A. So my focus right this moment is A. Okay? So I'm going to focus on just the ones that have A. There's A. A. So there's only 3, right? There's only 3 that have A. So my bottom number is 3. Now, out of those 3, remember that's the given that. Which ones are black? Well, there's only this one here. 1 out of the 3. Okay? 1 out of the 3. All right, that one's done. Let's move on to the next one. We're trying to find the probability that it's C, given that it's white. So again, my focus is the white ones, because that's my given that. So I have this one, this one, this one, this one, this one, and that one. That's 1, 2, 3, 4, 5, 6 is my bottom number. And then, of course, out of those that I have highlighted, and only those that I have highlighted, how many are C's? Just this one right here. So 1 out of 6. So that's done. And then the last one, we want to do the probability that it's black, given that it's a B or an E. So our focus is all the B's and E's, okay? So that includes this one, this one, this one, this one, and that one. Did I miss any? It looks like 5. There are 5 of them. Now, out of just those 5, how many are black? Well, we have this one is black, this one is black, and that one is black. These two are white, they're not. So that's 3 out of the 5. Okay? Conditional probability. Okay? Hopefully you guys understand that quite well. All right. So, long one here. I'm just going to jump right to the answer. We're trying to find the probability that the child that's randomly selected signed up for swimming, given that they are not in arts and crafts. Okay? Not arts and crafts. So we're going to do one of those circle diagrams here, because the two things that we have being compared are swim and arts and crafts. And what they told us is, out of the 125 kids that are at this place, 125, we know that 45 signed up for swimming and 38 signed up for arts and crafts. Now, we know that means then some did not sign up for either of those, because those two numbers themselves even don't add up to 125 kids. Now, it says 12 of those signed up for both. Okay, so 12 are in the middle. That means we have 45 minus 12, 33, who did swimming only. And then we have 38 minus 12, 26 who did arts and crafts only. So here we go. Let's do those who did not sign up for arts and crafts. Well, not arts and crafts is my bottom number. Well, who did sign up for arts and crafts? 38 people did. Well, 38 out of how many? 125. So see, 125 minus 38 did not sign up for arts and crafts. So that's 87 people who did not sign up for arts and crafts. Now, of those 87, now look guys, that's including not this group right here, right? Not that group. So out of not that group, how many actually signed up for swimming? 33. So 33 out of 87. And that will actually reduce down to 11 out of 29. So there you have it. That was probably one of the harder ones on the homework assignment. When we went to the back, I'd say you guys probably just blew through this. Okay, so number 12, again, remember, there's no given that on A. So my bottom number is my total number, right? And my total number here is all of these added up. So I went ahead and added 78 plus 30 plus 18 plus 24, and that's 150 people, okay? Now, out of those entire group, because this is the probability of student, it gives no given that. We're not narrowing down our group. We're just focused on the whole. So out of that whole group, how many are a student with a part-time job without a car? Part-time job, yes. No car. Right here, 30. 30 out of 150 will reduce to 1 out of 5. Okay, B. No car, given that it does not have a part-time job. So again, remember, my focus narrows. Given that they do not have a part-time job, so no part-time job. This is the only group I'm looking at in this particular problem. So my bottom number is made up of that group only. So 18 plus 24 is 42. Now, out of that group only, how many have no car? Well, that's this 24 number right here. 24 out of 42. So that reduces to 4 out of 7. Let me erase this. Whoops, wrong button. Let me erase that, and here we'll start again. A part-time, probability of a part-time job, given that they have a car. So we're focused only on those who have a car. We're focused only on this group alone. 78 plus 18 is 96. That's who we're focused on. Now, out of that group alone, how many have a part-time job? Well, yes, 78 have it. So 78 over 96 does in fact reduce to 13 out of 16. And that's it. That's it for that problem. Last one, number 13. Remember, A says probability of a third class survivor. So again, there's no given that. We're not narrowing our field down. We're talking about this whole group. Okay, so the whole group is all of these numbers added up. So I just grabbed my calculator and I just added them all up. 199 plus 117 plus 172 plus 120, blah, 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 blah. And that's 1,300. So out of that whole group, how many are a third class survivor? Third class survivor, 172 out of 1,300, which reduces down to 43 out of 325. Okay, so that one didn't narrow because there was no given that. But when we jump to B, it does. The probability, first class, given that they died. We're only focused on the group who passed away. We're only focused on 120 plus 155 plus 537, which is 812 people. Now, out of those 812 people, how many were first class? 120. So 120 out of 812 reduces down to 20 over 203. Okay, if you didn't get those, hopefully you're understanding this now. Last two, probability that they survived given that they were second class. So our focus is the given that, the second class. That's 117 plus 155, which is 272. Now, out of that group, how many survived? 117. Now, if you go type that in your calculator, it won't reduce, so we just leave it be. And last one, first or third class, given that they survived. So our focus now is only on those survivors. So we're going to add up all of those. That's going to be our bottom number, our given that. So all that adds up to 488. Now, out of that group, they could be first or third class. So both of those two. So 199 plus 172 equals 371. That's how many, and that one won't reduce either, but that's how many first or third class of those who survived. So conditional probability, I think you guys probably did quite well with it. All right, we are going to move right along to our probability review now. So this paper should be with you at this point, and you should be ready to roll. We've got all these up here that could be something potentially on this quiz that you need to be familiar with. We've talked about in the last week or so. Remember, the quizzes that I give are never really tricky. They're always supposed to be very straightforward, and this one will be the same, okay? So let's knock this out. Here we go. Jake randomly selects a letter from the word carelessness. What's the probability he selects a vowel? All right, so again, this is just simple probability, right? What's going to be our bottom number? Well, remember, this is just favorable over total. Total is going to be how many letters are in this word. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is my bottom number. And now my focus then becomes my vowels. We got A, E, I's no, O's no, U's no. That's it. It's just just one A and 3 E's. So that's 4 out of 12, which definitely reduces to 1/3. Okay? Just simple probability. Moving along, number 2. Kate is randomly choosing a date in the month of August. Okay, now again, go up there, and I'll leave that up there. August is one of the big ones. So that's 31. 31. Now, what's the probability that she chooses a two-digit number or a prime number? Okay, all right, so this is kind of getting tricky. 2 digits. Well, 2 digits would be anything from 10 to 31, right? 10 to 31. So you can count those up real quick, or you can subtract and then add 1. 31 minus 10 is 21, but because you include the 10, that's 22 that are 2 digits. Plus, we got some primes as well, right? Primes. Remember, primes, we already kind of listed those from 1 to 50. From 1 to 31, here they are. That's 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and 31. Y'all should be pretty familiar with these right now. Okay, so I don't find this to be a difficult thing. So that's how many out of those 31 days? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But here's my question. Were there any overlaps? Are there any numbers that actually fit in both the 2 digits and the primes? Well, sure there are. Okay, 11, 13, 17, 19, 23, 29, and 31, they got counted in both groups. So we have to subtract those that got double counted. So out of those 31 numbers in the month of August, those 1, 2, 3, 4, 5, 6, 7 got double counted in both categories. So you have to subtract those that got double counted. So it's 22 over 31 plus 11 over 31 minus the ones that got double counted, 7 over 31. And if you type that in your calculator, you get 26 out of 31. And that's your answer. Okay? All right, moving along. Number 3. And I know the tricky thing is just keeping this all straight in your mind. You can do it. You just have to think about the specifics when you're doing these. You can do this, I promise. A number 1 through 30 is randomly selected, followed by a letter from the word target. So look, we're actually choosing two things, right? A number and then a letter. What's the probability of choosing a perfect square from that 1 through 30 and then the letter T from the word target? So remember, when you have a single thing being chosen, it's a single probability. But when you've got multiple, you've got to multiply those probabilities. So let's start with the first one. Out of the numbers 1 through 30, so that's 30 numbers, right? What was the probability that there's a perfect square in those first 30 numbers? Well, here are perfect squares. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. That's over. So it's just the 1, 2, 3, 4, 5 possibilities out of those 30 numbers. Now, what about the word target? What's my total number? Well, there's 6 letters, right? But they want to know, what's the probability of choosing the letter T? Well, there's 2 of them out of those 6. So the chance of me choosing a perfect square out of the numbers 1 through 30 and multiply the letter T from the word target is 2 over 6. So 5 over 30 times 2 over 6, if you type that in your calculator, is a 1 out of 18 chance. Okay? Multiple probabilities, multiply probabilities. Number 4, Eric is randomly choosing a card from a standard deck of playing cards. Now remember, y'all have a little bit of knowledge. You know there's 52 cards, there's 4 suits, 2 of those suits are black, 2 of those suits are red. You know all the cards that are in there. So what's the probability that he chooses a card that is red or a spade? So remember, or means I'm just choosing one time, and I need to know if it's this or that. So I'm not doing multiple things. So I'm not multiplying. Or reminds me that I'm adding. Okay, I'm adding probability. So first, what's the probability to choose a card that's red? Remember, there's 2 suits that are red. So that's either 1/2, or technically it's 26 out of 52, which we know will break down to 1/2. And then what about spades? Well, remember, spades is one of the black ones. So there's 13 that are spades out of all 52. Now here's my question. Is this one kind of like number 2? Was there overlap? Were there red cards that were also spades? No, because spades are black. So there's no overlap, so I don't have to subtract anything. So 26 over 52 plus 13 over 52 will give me my answer, and that is 3 over 4. Okay, moving on. Number 5, a pet store has 45 parakeets. 21 parakeets are blue, 9 males, 12 females, and 24 parakeets are green, 14 males, 10 females. No final parenthesis. What is the probability that a randomly chosen parakeet is green or male? Again, the word or, that kind of keys me in. So I know I'm adding probability. So let's go ahead and do that. And let's just focus on the green parakeets. Well, we know there's 45 total, correct? Of those 45 total, how many are green? 24. Okay, now let's just focus on the males. Again, we know that there are 45 parakeets. How many are males? Well, we have 9 that were blue and 14 there. So just males, we have 14 plus 9, which is 23. Correct? Now here's my question. Is this one more like number 2, or is it more like number 4? Is there overlap or is there no overlap? Well, of course there's overlap. Think about it. There are green parakeets that are males. There are 14 of them. They got counted under both categories. So therefore, we have to subtract those in order to get rid of them. So if you type all of that into your calculator, it will simplify to 11 over 15. Number 6. Carter is handing out Valentine's cards to his friends. He has 8 Batman cards, 12 Superman cards, and 5 Captain America cards in a bag. He selects a card and gives it to a friend, and then selects a card and gives it to another friend. What's the probability that both cards he selects are Batman? Okay, so first of all, there's one real key concept in this problem. Let's say there's 2. 1, how many cards is he giving out? 2. 2 different cards. If there's multiple cards, then there's multiple probabilities. So we're going to multiply our probabilities. Okay? The second concept that we talked about when we studied this particular lesson was, is it replaced or is it not replaced? Is it independent or is it dependent? Well, in this one, the key thing here is he gives it to a friend. You see, if he takes the first card out and he gives it to the friend, is he going to snatch it right back and then put it back into his hat or into his bag? Of course not. He gives it. It's gone. Okay, so this one is what we call dependent, because what you do the first time does affect what happens the second time. I hope that makes sense. So let's talk about the probability of just the first one happening. Okay, he reaches into this bag. How many cards are in there? Well, there's 8 plus 12, 20 plus 5. There's 25 cards. How many favorable outcomes are there of him pulling out a Batman card? Well, there's 8, right? So he had an 8 out of 25 chance of pulling out a Batman card first. So let's say he did that. He happened to have gotten one. He gives it to his friend. He reaches back into his bag. How many cards are now in there? Now only 24. And on top of that, how many Batman cards are still in there? Now there's only 7. So it's 8 out of 25 times 7 over 24. If you type that in your calculator, it reduces to 7 over 75. Okay, so there's page 1. I hope that all that is crystal clear and that you're going to be able to do that. A couple of things just to remind you. 1, don't forget about the days of the month. I'm going to leave that up there on the board. Hopefully you can see that. If not, maybe you memorize it. It's not that hard. Also remember things like perfect squares and prime numbers. Know some things about a standard deck of cards, and you should be fine with all of these probabilities. Okay? The rest of the stuff pretty much comes from given information. Okay? So it's more experimental, really, because it's coming from data. So here's the backside, okay? We've got a bag containing 25 red chips, 18 blue, and 29 yellow, okay? So let's go ahead and add those up real quick. 25 plus 18 plus 29 is a total of 72. I'm going to just jot that down so I don't forget it. 72 chips in this bag. It says a chip is selected, and then look at the wording right here. Replaced. Okay, it's put back in. It's replaced. It's independent. What I do the first time does not affect the second time because I put it back in. So what's the probability that I pull a blue one out and then a red? So again, multiple probability, multiply probability. So let's talk about blue. We know that the bottom numbers are total. That's 72 chips. I reach into this bag. How many blue chips are there in there? There's 18. So you did it. You reached in there, you got your blue chip, you throw it back in the bag, you reach down in there. How many chips are still in the bag? Well, 72. They're all in there still, right? You put it back. Now, this time, what's the probability that it's red? Well, that's 25 out of 72. So my probability of pulling out a blue and then a red is 18 over 72 times 25 over 72. If you type that in your calculator, it ends up giving you 25 over 288. Excuse me. Okay, I know that sounds terrible, but I'm actually feeling better today. I feel more like a human the last couple of days. I'm sure you guys were worried about me. But anyways, Next one, probability of a yellow and then a blue. Again, that's two probabilities, so multiple probabilities when multiplying probability, okay? Now, reach down this bag. What was the probability it was yellow? 29 out of 72. I put that back into the bag. I reached down in it again. What was the probability of pulling out a blue one? Well, that's 18 out of 72. So to come up with this answer, we're going to go 29 over 72 times 18 over 72, and that one is 29 out of 288. So there is the concept of something being replaced, okay? It does not affect probability because it goes back in the bag. So what you did the first time doesn't affect what you do the second time. The next group is a little different. Look what it says. It says a box of pizza contains 3 cheese slices, 7 pepperoni slices, and 5 supreme. Mark randomly chooses a slice. He eats it, and then he chooses another. You notice why this one is definitely the other category. This one's dependent because he eats the pizza. If he eats the pizza, it's not back in the box. It's gone. That makes sense. I know it does. So it's very much a dependent problem. Now, let's do the same thing. Multiple probabilities. We're going to multiply probabilities. So I reach in the box. What's the probability I grab a cheese? Well, there are 3 cheese slices out of the total. Well, that's 3 plus 7, 10 plus 5. That's 15 slices. So I had a 3 out of 15 chance of grabbing a cheese. Let's say I did it. I eat it. Well, Mark eats it. Then he reaches back into the box. How many pieces of pizza are still in the box? Now there's only 14, right? One of them's gone. I just ate it. Or Mark just ate it. Now, what's his chance of grabbing a Supreme? Well, there's 5 left of those. So it's 3 out of 15 times 5 over 14, which reduces to 1 out of 14. Got a 1 out of 14 chance of both of those two things happening. All right, number 10. What's the probability of pulling out 2 pepperonis? All right, so again, multiple probability, we're going to multiply probability. All right, I reach down into this bag or this box. What's the chance of me getting a pepperoni? 7 out of 15, right? 7 out of 15. You eat that piece of pizza. You reach back in the box. How many pieces of pizza are in the box now? Only 14. And how many pieces of pepperonis are still there? 6. That's it. So it's 7 out of 15 times 6 out of 14. If you type that in your calculator, that reduces to 1 out of 5. 1/5. All right. So far, I feel like we're probably doing pretty good. Number 11 might be one of the more challenging problems on the quiz. So let's look at this one. Of the 318 sophomores, 140 are taking Algebra 2 and 102 are taking Chemistry. 26 are taking Algebra 2 and Chemistry. Okay, so we got one of these circle diagrams, okay? And we're comparing two things. Students that are taking Algebra 2 and those that are taking Chemistry. The ones that are in both categories, the overlap, is the 26. So let's find out how many are just in each category. If 140 are taking Algebra 2, 140 minus 26 is 114. About Chemistry, there's 102 taking it. If you take the 26 away, that's 76 who are taking Chemistry only. All right, so let's see what this says. If a sophomore is chosen at random. Now remember, there are 318 sophomores, okay? If a sophomore is chosen at random, find the probability that they are taking Algebra 2 if it is known that they are taking Chemistry. Okay, so look, guys, we've got to start with our it is known that they are taking Chemistry. That's our given that, okay? It is known that they are taking Chemistry. Guys, they are taking Chemistry is my given that. How many people are definitely taking Chemistry? All of this circle, right? That's my given that. All of that circle. All the people that are taking Chemistry. That's 102 people. Okay? Of that group that I have highlighted, those that are taking Chemistry, out of that group, Find the probability that they are also taking algebra 2. Well, that's the overlap. 26 out of 102 is this problem. So that reduces down to 13 over 51, and that's my answer. Okay? I promise the one tomorrow will be a lot like that, okay? Shouldn't be that hard for you. Okay, and then these last ones, I think you guys are probably pretty good at these. Let's work through these, and then we'll be done. Look at the first one, okay? Don't let it get you thrown off. Do you see any given that? It just says, find the probability a male that owns an Android. So remember, if there's no given that, we're not separating this data. We're not focusing in on any category. We're talking about the whole thing. So grab your calculator and go 34 plus 30 plus 19 plus 42, and that's 125. Now, out of that 125, how many are a male that owns an Android? 34. 34. So that's 34 over 125, which I don't believe that reduces. So that's my answer. Okay, now, all of a sudden, we have given that's. What's the probability that's Apple? Given that it's a male. Given that it's a male, that's our focus. We're only looking at this category, males. That category has 64 total people in it, okay? 64 total people. Now, of that category, how many are apples? 30. 30 out of 64. I know that will reduce. It reduces down to 15 out of 32. Remember, guys, if you can reduce it, go ahead and reduce it. Okay, let your calculator do that work for you. And then the last one from this group, here's my given that. Given that's Android. Okay, so again, we're only focused on their Android category. That's 34 plus 19. Okay, so that's 53. We're only focused on 53 people. Now, of those 53 people, how many are female? 19. 19 out of 53 will not reduce, so that is my answer. Okay? Last ones, there are several here. 13. Again, you can look at all those. Sorry, excuse me. On the bronze, or I'm sorry, on A, see no given that, do you? So my bottom number is my total. So let's go add these up real quick. 46 plus 28 plus 29 plus 38 plus 28 plus 22. That all adds up to equal 191. Kind of a random number. 191. I hope I add that right. Now, from all of them, how many are a U.S. bronze medal? A U.S. bronze medal is right there. 29 out of the total 191. I don't believe that reduces. I did not get a reducing value, so I think that's it. Okay, ignore that now. Let's move to B. Again, do you see a given that? No, it's just a probability of a gold or a silver. There's no given that anything. So we're still talking about our total, 191. Now, who could we deal with? Well, a gold. Those are all gold. Or a silver. Well, those are all silver. So we're talking about all of those, right? It could be in any of those. They didn't categorize it anything else. So you actually have to add all those up. So you've got 46 plus 38, that's your gold, plus 28 plus 28, that's your silver. So that's 140 out of that total 191. Again, that will not reduce, so there you have it. Okay? All right, last three do have given that's. So let's start here with C. The probability that's silver, given that it was China. So we're only focused on this column, China. Okay, that's our given that. So count those up. 38 plus 28 plus 22 is 88. 88. Now, out of that group, how many are silver? 28 out of 88. That will reduce to 7 over 22. Okay? Next one, D. Probability that's US, given that it was a gold. So we're only focused on the gold. Okay? That's our category. That's our bottom number. So 46 plus 38 is 84. Now, of those 84 I have highlighted in red, how many are US? 46. 46 out of 84 equals 23 over 42. And last one, and then this review and your preparation for the quiz is all for you. Okay, this one's a little tricky. Probability that it's China, given that it's not silver. Not silver, guys. What does not silver mean? Not silver means it can be gold or it could be bronze. So we're adding all of those up. That's my bottom number. So grab a calculator. 46 plus 38 plus 29 plus 22. That's 135. Okay, so all of those that are highlighted red, those are what I could be dealing with, the not silvers. Now, of those groups that are highlighted red, which ones are China? 38 plus 22, which is 60. So 60 out of 135, and that will reduce to 4 out of 9. And that was probably the trickiest one here. You had to think a little bit more. Anyways, this video is now at about 41 minutes. That means that your time is up. I hope that you guys do well in the quiz tomorrow. Give it your best effort. And that's all I could really ask. Again, thank you guys for being patient with me. I promise you I would rather be there at school with you. But anyhow, we'll see you soon.